Maybe get that.
Okay, I started streaming, so is the stream up? Okay. Okay, let's get started. Again, welcome to the fifth day of the workshop. I believe many of the attendees have exams tomorrow, so we were informed that many would not be able to attend today. So we are gonna keep this day, this session pretty light, and it's gonna be more of revision and things that we did earlier. It will be more of recap and a few concepts that might be of help to you in the future. Okay, it's not gonna be heavy. It's gonna be very light, and you need not really code any much, anything in this session. So it'll be for 1 hour, and we hope that we can resume the actual hands-on session after everybody's back. So we want to get your feedback. In this session will be more of you talking rather than me, you asking questions, or you clearing your your aspects towards Prisma. Okay, so let's get started. Just give me a sec. Yes, perfect. So can anybody unmute and say, did you try cloning the repository? Did somebody find any problems so far? What's your ideology about what we've learned so far? Can anybody talk? Unmute and talk. How is this all going? Do you find it easy, or do you find it, it's totally Greek and Latin for me? What's your ideology on what we've done so far? I want people to talk. Why is nobody talking? I don't know. The very common problem that we are facing here is nobody comes up to talk, and workshops like these are conducted for people to talk and talk, interfere with people and interact with people. But since it's online and really nobody talks over here, it's understandable. But it's forums like these where you get to talk with people. Okay, and trust me, these forums are places where you can really do something. Okay, so just tell me if everything's all right. Were you able to follow the code, or what's happening?
Like I won't say it's easy and all, but I think can follow it to some extent. I sometimes refer to the YouTube link and try it out myself, play around with the code, and so, I'm catching up to it. Need more practice and stuff.
Okay, it feels like catching up to it. Okay.
Yeah.
Okay, you told me that there are some parts that might be overwhelming, right? I know from what you said, I infer that. So, what were the things that really gave you a hard time? So that we can look at it today.
Like first of all, setting up the whole setup was a huge problem because my PowerShell did not have like some permissions and stuff. I had to sort that out, and cloning the repository, I had to like repeat that steps for like 4 to 5 times to get it right. So yeah, first time I did not get everything, but slowly I got to understand like how to do stuff. So I'm pretty okay now.
Cool. Can somebody else give your opinion on this? Okay, let me give you a quick recap of what we've done so far. So, on the first day, we started looking at all these, what these endpoints are. We started setting up, like what Joe's told, right? We had to set up the project. We went to the PowerShell and we installed a few modules, and that's how we eventually started our Express web server. And in that web server, we were able to attach the first endpoint, and we were able to get some data out of it, right? We were able to return hello world from it. And over the next few days, we were able to set up NodeMon, recreate a server from an actual development standpoint, and we even looked at a few HTTP methods that we can use to talk with a server. We set up database, we looked at types of databases, and we even created our own database on Heroku. And I hope like everybody remembers how you do this, because most of your time, most of a developer's time would be setting up and getting things ready for your development, right? So these are very important things that you would primarily do when it comes to developing a backend. So the reason behind me taking 3 days for setting up the project and getting you familiar with all the things that we use in a project is because this is what you'll be doing as a backend developer. Your 60 to 70% of the time that you spend on the code will be you setting up the server, setting up the schema, and it's just introspecting the entire process. Okay, so that's why we took 3 days, and I mean more than that, to get started, right? So far we've done nothing. We didn't actually build a fully functional API. We built a web server, we built an endpoint, we built an API, but did we build a solution? No, we are yet to do that. Okay, so it's important that you understand what's happening here, what we've been doing, and how is it gonna be useful to us, right? Are we still on the same page? Guys?
Yes.
Cool. Right, so we looked at Prisma, and I was telling you that Prisma actually makes things easier. All these introspecting, all these database setting up things, and writing your blueprints. Prisma basically did most of the things out of the box for us. And we even looked at TypeScript. It's totally a new, it's not a new, it's a superset of JavaScript. And I also showed you how it can be of help when it comes to filtering, or when it comes to types, and so that you reduce the number of errors when you develop a backend, right? So we did that. So I think we even looked at, am I missing out something? We looked at middleware, right? We looked at middleware. We looked at how we handle errors. We looked at a few error status codes, like error 404. We looked at error 500 and how you throw these errors, right? And we looked at headers. We looked at a few middlewares. Am I missing out something? Can somebody help me if I missed out something? So far I believe most of these topics would have been ambiguous, or it might have been somehow touching the surface. But in order for you to get deep into it, you have to get your hands on and you have to do something in it, right? And that's why we will be giving you a task over the next few days. The next session will be the last session. We will be talking about authorizing your endpoints, how you can provide security. We've been aiming to do that for a very long time now, and we actually weren't able to do that due to time constraints. And honestly speaking, any workshop session greater than 1 hour is gonna be boring, trust me. So we want to keep it within 1 hour, and we don't want to waste time. So we thought this session, provided that you have an exam tomorrow, we'll be talking about what we did in earlier sessions, and we'll be talking about a few concepts that aren't like really crucial to what we are going to be doing here, but it's always good that you know this. Okay, so actually we were talking about a few databases, right? Do you remember what were the types of databases that we learned? Can somebody help me? Anybody?
SQL and NoSQL.
SQL and NoSQL. Does anybody know any other databases? I mean, we have databases, we have SQL databases, we have NoSQL databases, and these are broad classifications, okay? But has anybody heard of any other databases other than Postgres? And you have what we talked about, mongoDB being a NoSQL database, where you store data in terms of key value pairs, you store data as collections, not as tables of rows and columns, right? Has anybody come across any other database paradigms? Anybody? Okay, so anyways, the entire backend community, the developers who build backend, they actually use more than a bunch of databases. I told you, in any project you would choose a type of database that suits your requirements, right? So in a case of building a library management system, it's basically structured. All the data that you're going to collect is going to be predefined. In any database that you build for a library management system, what are the entities that you might always have? You might have books. You might have resources that say authors. You might have resources that say the readers, right? So all this data is pretty much structured. We know what data we are going to collect. We know how this data will be collected. We know how it needs to be saved in the database. We know the blueprint. So in these cases, we can use a structured database. We can go with a SQL database. SQL databases, in terms, I mean, you can use Postgres. You have a lot of other solutions other than Postgres. You have MariaDB, you have MySQLDB, and things like that. Okay. And when it comes to undefined structures in databases, let's say you are building a platform, and in this platform is basically a blogging platform. Let's say this is a blogging platform. Of course, here you have a lot of structured data. You have of course, there is going to be a set of posts that you will be blogging. There will be a set of let's say you have comments, you have ratings, reviews for your blog, and things like that. This is structured. But let's say tomorrow you don't want this blogging platform to just be a blogging platform. You want to be able to add more features, or let's say you want to be able to add more attributes, and this any blog would probably have the title, the description, and probably the author's name and things like that. But tomorrow, what if you want to add in more attributes? Let's say that blog needs to have a social media integration. That blog needs to have a connection to another third-party provider. So in these cases, when you don't know what the structure is going to be, when you don't know how this blueprint might change in the future, you usually go with a NoSQL database. So over there's no structure. You just have collections, and this collections does not need to have a schema. So you need not worry about missing an attribute. Even if you miss an attribute, it's not going to do anything. It's going to say, okay, yeah, this collection didn't have this document didn't have this attribute, but this document has. So I think you get what I'm trying to say here. Okay, when it's structured, and when you know what the data that you're going to collect, and if it's not going to change in the future, you would probably stick with SQL. And again, there's another catch here. Okay, it's not that you would probably stick to this. It's totally up to the developer's convenience, because you can achieve the same the things that you do in a relational database in a NoSQL database. You have IDs, you have relations in that where you can achieve it in a different way. Okay, so it's when you look back, it all boils down to the developer's expertise in a particular database. Okay. So if you're convenient in using a NoSQL database, if you're convenient, and if you think tomorrow the number of features or number of attributes that any resource might have can dynamically change, you would probably stick to a NoSQL database if you prefer that. So just know this: any database that you will be using for your backend, it's completely up to you. You can use anything. Okay, but just stick to the requirement that I told you. If the data is going to be dynamically changing in the future, and you don't know what attributes any resource might have, you would probably use NoSQL. So when you know everything's fixed and everything's structured, nothing's going to change. So like a library management system, there's no feature that you can add. There's no more attributes that you can have on any book, right? So over there, you would probably stick to a SQL database. Apart from NoSQL and SQL databases, and so far we've looked at Postgres, we've looked at mongoDB and things like that. There are other types of databases that people would normally not know, okay, but these databases are actually things that you would be using daily, okay. For example, you have WhatsApp, right? You have WhatsApp, and ever heard of SQLite? There's this particular DB solution that goes under the name SQLite, SQLite. Anybody who's familiar with Android development, and people might know. Okay. So even if you don't know, please unmute and talk to me. It feels lonely. Nobody?
Oh, bro.
Cool. So basically, you have this. It's more of an offline DB solution that most Androids have it inbuilt. Okay. So all your media thumbnails and it basically needs a database, right? Any app that you have, it needs a database. Even if it doesn't have an internet connection, you need this data to be there, right? To achieve this, Android has an inbuilt DB solution that goes under the name SQLite. It's another DB software. So what this does is it's again similar to it's a SQL database, and you store things. What we do here, we do it on your phone. You have been using a different database without even knowing that. And other types would include I don't know if you know this. There's another database that goes under the name Redis. Okay, Redis is not a conventional database, and Redis is more of a caching database. Okay, all the database that you have right now, we have SQL, you have NoSQL. All the data that you put into goes and gets itself stored in any hard drives, right? You have all these secondary storage devices, any hard drives or SSDs, or basically your storage mechanism. So anything that you put on these conventional databases goes to themselves in your disks. It might be an SSD, it might be a hard drive, but on the cloud, it's stored on a disk. But when it comes to Redis, it's stored on your RAM. It is stored on your memory, and usually backend developers prefer this type of database as a caching mechanism. Okay, when I say caching, you know what's caching. It's like a temporary buffer where you can store data for immediate retrieval, right? So let's say you have a DB, and this DB has collections of profiles. You have Facebook's profiles, and in terms of Facebook, you might have millions and millions of records. Okay, you don't want this. Let's say you have a particular resource that you would require on every single page. Okay, so what would normally the front-end developer do is he will talk to our backend, fetch the profiles information from the conventional DB. Let's say we have Postgres, and he'll have to talk to the Postgres DB and get the profile information, right? But when you have Redis, I told you Redis is a caching mechanism. It's more of a DB that's going to be running on your RAM. So of course it's going to be faster than regular databases. So people will have this DB as a middle DB. So whenever they go and fetch the profile from the Postgres, they take it and put it inside this Redis DB. So every time after that, once that caching is done, now when the user tries to get his profile, it's 100 times faster than the previous way, because you are not going to be fetching data from the database. You are not going to iterate and find the data from the database. You already have it cached in this Redis DB server. So I'm talking about all these DB concepts or DB paradigms so that you know that any backend solution does not always need to have one DB solution, right? You don't need to stick to one DB. Of course, you have different requirements, and most of the solutions that you find online, most of the big huge companies that you see on the internet are running while using more than 3 databases, different databases. They might have a caching DB server, they might have a SQL DB server, they might have a NoSQL DB server for a tagging engine or a search engine, right? So are we clear? Do you get what these types of databases are and how you can have multiple databases on a single project? Cool. Again, and the other thing that I wanted to talk about was API versioning. Okay, so initially when we started this workshop, I told you that we will be looking at concepts that pertain to scalability and enterprise grade software engineering. Okay, so I don't know if you've noticed, most of the topics that we covered might not be of use right now, but when you look on the long run, when you are building a software for an enterprise, all these small concepts will come and hit your mind in a way that, okay, this is how I fix this problem. Okay, so one of that such requirement is API versioning. Okay, in any API development environment or in any API, developers would have to build multiple versions. So let's say you started developing an API, and this API you built it on Postgres. Tomorrow the client, or there is such a requirement where people expect you to change it to a mongoDB, expect you to change it to a NoSQL database, okay, a different type of database. What would you do? But the existing front end is based on the Postgres API that you built earlier, right? So you don't want the existing front end. Let's say this front end is version 1 and you have this backend which goes under version 1. So you have been building this Postgres that goes under version 1. So tomorrow you are developing the second version which uses mongoDB as the DB solution. So what you will do is you will deploy this second version on a different solution and probably route it on a different way, on a different endpoint, so that the second version of the front end, the second version of the front end would probably use your second version of the API, and the first version of the front end will still be using your front end. Will still be using your backend that was on version 1. So when I talk about API versioning, it's very, very important, and it needs to be done whenever you build a scalable project. You need to version your APIs. Okay, how do you version APIs? Okay, that's what we're gonna look now. We're gonna look at it now. There are actually 3 ways where you can achieve this. So yep, you would have seen this already. The first way of versioning your API is by URLs. Okay, so if you've noticed, when we use the NASA's API, we had API. The URL was similar to this. We had HTTPS, we had API.nasa.gov, and it had v1 and it had the other endpoints, whatever. So I think it's clear now, right? So this is what we saw that day. We noticed that there was a version number. So this type is API versioning by URLs. Okay, so you are basically having different routes for different versions of the API. So let's say your front end, the developer who was building your front end, started using this API, and tomorrow he prefers to build another second version of the front end that uses a totally different version of the backend. So in order to change the version of the backend that he is using, you would just come to this API URL. He'll just change it to the version that he requires. So now the backend is going to be a newer version, and maybe the data response might be different, maybe the way you talk to this different version might be different. Okay, so this is how you handle API versioning through URLs. And the second version is you have API routing using headers, and this is really, this is one of the commonly used ways you can set up API versioning through headers. Okay, let's get back to Postman. In Postman, if you notice, I told you every HTTP object has a header, right? It has a header, it has a payload, it has a body, it has other metrics or factors or the other structures. So let's look at this API response. Okay, our API response object, it had a body, and we were able to retrieve that body. What people would normally do is, whenever they request an API, they would probably have this headers, and over this header they might say they'll give another key that goes by the name version, and let's say they have 1.1.2, and now the server would be able to read this header and route it properly to whichever endpoint he needs to, right? So this, I think you get it, right? Whenever you want to route a user's request to a different version of an API, you would look at this header and understand, okay, this guy needs to be routed to a API that goes under the version 1.12. So the server would be able to read this version and do the necessary action, and that's one way. So far we looked at how you can route API versions using URLs. We did the URL, we had /v1, and we did the resource. And the next way would be doing this header. So you'll just set another additional header that goes under the name version, or you can probably have any other keys, and this you should be handling it on the server. So at the server you would probably read the request object, check if there's this version header, and check the value under it, and you will route it accordingly. Am I being clear? So far we looked at two different ways you can version your API. Are we clear?
Yes.
Cool. And the third method is one of the most simplest and most commonly done method. You have this domain, right? We had NASA's domain. It was like this, and over here, let's say this is the primary version, and this is the production version. But let's say you have a version that you use only for testing, okay? And this version shouldn't be it should have a way to be accessible, right? So what you do is, you take the different version of this endpoint. You have this entire server, right? You take that and you deploy it under a different domain. So now we will say api-test.nasa.government. So now whenever somebody hits this endpoint, it's not going to be the production endpoint, it's going to be the test version of the API. Am I being clear? So there are three ways you can version an API. You do that by URLs, you do that by headers, you do that by domain. The most commonly seen ways are by domains and URLs. Headers, not so much, but still most companies do this so that their endpoint looks cleaner, right? They don't want to have api-test.nasa.gov, or they don't want to have api.nasa.gov/v1, v2, or whatever. Am I being clear? Cool. Okay, let's get back to routers. Yesterday we started routers, and I think not many understood it, and I think we rushed it. We didn't even look at what routers are. So let's get back to routers and understand what's actually happening in routers. Is my screen glitching or is it okay?
It's okay.
It's okay. So if you remember, in our old, in our first web server, we had an index.js file, right? And in that file, we declared a few endpoints. So let's say we had server.get, and we did something like this. We had an endpoint that goes under the base URL, or let's say we had users, and we had a handler. So this was basically our controller, right? So let's say this controller creates or gets user details. Right? You remember this, right, everybody?
Yes.
Okay, cool. We even declared another set of endpoint, maybe the same endpoint that handles post requests. So it would probably look like this. And instead of get details, you would probably define another controller that creates user details, creates a user, right? And this was all done in the same file. And let's say you have another resource that goes under the name organizations, and here you would probably create an organization, or let's say this is a get endpoint. So yes, so it's similar, right? You get what's actually happening here. You have a file and you have specific endpoints and you declare controllers for it. But is it really ideal? What might go wrong if I keep doing this? Can somebody point out? I can do everything in the same file, right? I can probably do everything on the same file and deploy it. What might go wrong if I keep doing this? What if I want to add more endpoints to it? Right now I have users and organizations. What if I want to have slash users slash organizations? Or what if I want to have users and probably their profiles? I might have n number of resources or n number of endpoints, and I keep doing it. I keep declaring routes. I keep declaring endpoints in the same file. What might go wrong? Can somebody point it out? Nothing would go wrong. Yeah?
You can't keep track of the routes you have done so far if you want to.
Exactly. You can't keep track of the routes. So let's say you have 100 endpoints in an API. Okay, you have 100 endpoints. So as a developer, I told you your project structure is very, very important. And if you declare all the endpoints in the same file, it's not really neat. It's not really the ideal way to do it. Instead, what you do is you take a different file. Let's call it users.js. Okay. Now what you do is you declare all the endpoints here. Let's call it users.get. Okay. Instead of doing it over here, I just replicate it over here. And instead of server, I call it user, and over here I say user. Right? And now I don't do this. Let's say I remove this. Now what I'm going to do is I'm going to say let me import all the endpoints that are available on this file. And point our server to use that endpoints. So now what happens is, I think it's pretty obvious, right? You have all the endpoints that goes under users on an external file. You declare all these endpoints over there, and you export this. You export this, all these endpoints. Okay, you export this and you import it in the index file. And now what you do is you make sure that all these user routes go under users. So even though it's relatively the base URL in the users file, at the top you say it's the users endpoint. Am I being clear? So far is it clear? Before you were declaring all the endpoints on the same file. Now what you did was you took all the endpoints, you put it on a different file, you export the endpoints, you import them in this file, and route it, right? So it's nothing new. It's what we've been doing so far. We are just doing it in a modular fashion, right? So that your code looks clean. Is it clear?
So when we do this, like the endpoint gets changed from the root directory to /users.
Yes. So think of it as a relative address. You call this a relative addressing. When you look at the users within the users declaration, whenever you look at within the users file, over here, let's call it router. Just for the sake of understanding. Okay. I don't know, for some weird reason. Cool. You declare a new router. So just understand this. In this file, you create a new router, and this router will basically handle all the routes and controllers within it. And finally, after declaring all your endpoints and what it needs to do, you export that router. Okay. This exported router gets imported in the main file. The main file is gonna be the entry point. So whenever our web server reads this endpoint, it knows that I need to import the router from the users.js file. Now, even though it's the base route in the users file, we are internally mapping it to use the users endpoint, right? Is it clear? So you might ask,
Yes.
It says base URL, there's no route over here. But instead of declaring the route inside this file, I'm gonna say the base route, and when I go into the index file, I say users. So now whatever endpoints that are being routed on this router gets mapped to the endpoint users, right? So I'm gonna give you a quick question. So what if I want to do something like users slash post? How do I declare this? Can somebody help me? I want to declare an endpoint that goes under the route users slash posts. Where do I declare it?
Server.use users/post.
No. What did I tell? Anything that comes under users should be under the users or on a separate file, right? Take another guess.
Inside users.js we have a route name /post.
Perfect. So what do you do here?
Router.post
Router.post or whatever. what do you put in your
/post.
post? And of course you do something like create post. Does everybody get it? I needed to have I wanted to have one endpoint that goes under users, and we already routed the users endpoint to this file. So anything that gets anything that's defined in this router will obviously be routed to the users endpoint, since we did that in the index.js file. Is it clear? Guys?
Yeah, sure.
I don't understand the post
You don't understand the post. Okay.
because, like in previous examples, like
Mm-mm.
just the slash implies the root directory, but
Yes.
we use it in the index directory. We give slash users, which routes it to the users. But here,
Yes.
slash post, it's like the post comes after the user, right? I don't get that. I'm confused.
Okay. Let me give you another example. Don't assume that this just slash alone gets you the root directory. No. Anywhere the base, you call this the base route. You call this the index. You don't call it the root. I think you got that part wrong, because when I say it's the root within this file, relatively it's the root, right? Understand the word when I say relative to this file, comparatively within this file, you say this is the end, this is the route. So I take this file, in the index file I route it to users. So whenever I route anything inside the users, it's gonna get automatically mapped to the slash users. So when I want to declare another endpoint that goes under users slash posts, I already have an endpoint that maps users for me, right? I already have an endpoint that maps users for me. And if I want to have another endpoint that is mapped further into users, that comes under users, you have users, you have slash post, and it's under users, right? So in order to do that, you take this users.file and you create a new endpoint within that. So even though it's the root, it's relative to this file. It's not the root of the entire application, right? You get it?
Yeah, bro. Now I get it.
Cool. Understand the word relative. So that's the key thing that you would need to remember in any router. Okay?
Yes.
I mean, is everybody clear with this? This is fundamentally everything that you need to learn when it comes to router. You need to understand that the relative addressing, right? You have something called relative addressing and an absolute addressing. When we talk about router basically addresses it relatively. So when you export this router somewhere and start using it, probably in the index file, there you can say it's an absolute address. Okay, so anything you declare on the index file, there's nothing above this, right? There's no declarations above this, and this is where you declare the routes on your server. So beyond this, there won't be any routes. So you call this an apex endpoint. You call this the base URL, and you have base URL, the users, and after users, you can probably map it to any router. Am I being clear? So you can also have, this is another going deep down into the rabbit hole. So let's say you have more mappings under posts. So let's say you have post slash images, and let's say you have users slash post slash documents, and let's say you have n number of resources under posts. Again, there's this problem of declaring all the endpoints on the same file. What can be the solution? Can somebody guess this? we talked about how routers can be useful when it comes to mapping routes. So now we are going deep into the rabbit hole. We have user/post, and let's say post itself has deep nested routes, and we need to map that. What other solution can I do? Of course, I can keep declaring another endpoint that goes like post/documents. I can say post/images, but what's the ideal way to do it? What's the right way to do it? Can somebody guess?
Create another file.
Create another file that handles all the routes that come under posts. And what do you do after that?
Export there and import here.
Perfect. So now you understand what routers and how routers can be useful when it comes to mapping all your endpoints, right?
Yes.
Yes.
Perfect. So that's what you need when it comes to router. Okay, we will look at how it's being done in our project that we in the boilerplate that we imported yesterday. The other important thing that you need to know is a different syntax. It's not totally a new concept. So you have all this endpoint, right? So another standard that you need to maintain is, you can do this in a different way. You have router.route. Okay, I'll show you the comparison of how it actually looks. I'm gonna quickly copy paste this. This same file can be rewritten as this. Do you understand the difference between both of the files and the advantages of doing this? Can somebody point it out? What's the difference between both of these? And what can be the advantage of doing this over this? Anybody? Is anybody there on the call?
In one route, implementing all. In
Yes.
one route itself, you are implementing all. In up your for separate things, you have to implement separate actions now. So you are kind of repeating.
Yeah, exactly. We are repeating the same code. Instead, we define one route and declare all the possible methods that are available on the route below it, right? Now it looks more cleaner, and immediately when a developer comes and looks at this route file, he understands that, okay, this is the route that is available on the endpoint, and these are the methods that I can really access. But even if you look at this, I can of course understand what are the endpoints, but it looks really messy. Let's say somebody declares this route above this. So I don't really, when I immediately come to this file, I don't really know what are the available methods that I have on the base URL, right? I don't know. So when I look at this, it's pretty clear. I have one route, I have the possible endpoints that I can declare on that route, and that's it. It's simpler, right? So this is how you do. So this is how you route when it comes to scalability, and when it comes to building your enterprise grade applications. So of course we can, if you have a simple endpoint, if you have a very basic API that doesn't really do anything, it's just your utility, or it's just gonna have one endpoint. In those cases, you can probably set one post endpoint and get the job done. But when I say enterprise grade, you're building a really legitimate software, and you need that software to be routed properly, and it needs to run a long way, right? So in those cases, you do this. Okay. Do you have any doubts? Okay, so if you don't have any doubts, we'll quickly look at our project and understand what we've defined over there. We'll understand the boilerplate over and all, and over the next session we'll actually get started with what we were intending to do. Okay, so let's get started. After this, you can probably play with your boilerplate and yep.
அவன் அம்மா கூட போயிட்டான்.
I think somebody's on unmute. Cool. I hope the screen is visible.
Yes, it's visible.
Perfect. So let's look at the project. Okay, leave out all the configuration files, leave out all the linting documents. Let's get into the source directory. In any project, in any big huge project, you would normally put all your source code inside an src folder. Okay, this is very normal. This might be familiar when it comes to React projects or Next projects or any other JavaScript frameworks. You usually put all your code in src folder. So let's get into it. So you have src folder, and we have the index.ts file. And I told you throughout this entire project we will be using TypeScript as our main programming language. Okay, so the first file that is ever gonna run in our project is gonna be the index.ts file. It's the entry point. When we come inside that file, we have a .env dependency. Does anybody know what this package does? For the others to know what's actually happening here. I know many of you might have used this in your other projects, but can somebody help me explaining what this actually does? And why should we need a .env, or why should we use environment variables? Can somebody help me?
.env to store confidential data like API key, things like that.
Okay. What happens if I don't have an environment variable and directly put anything in my file?
Your API keys will be exposed to everyone. Your code will be saved.
Okay, cool. So actually what Joshua is trying to say is, so we had a database URI, right? We had a database string. What we did was, we had the database string, and normally we would put it wherever you initialize the DB Prisma, right? So let's say you have the Prisma folder, you have schema.prisma. Let's say you put the database URL directly in the file. Okay, and now since all of our projects are being pushed to GitHub, it's available on the internet for free, like anybody can look at your code. So what happens when somebody comes and looks at your DB URL? He will be able to access our database. Okay, you don't want that to happen, because your database is going to have confidential information. You might have user credentials, you might have passwords, and a lot of things that you don't really need to give to any other people. So whenever you push to GitHub, you don't really push these credentials. To overcome that, you would normally do this. You would declare a file that goes under the name .env, and you'll declare all the variables that you need over here. These are variables that would not really be tracked on any GitHub repositories. You won't really push this code, and that's why if you notice on the git ignore file, we added all the env extensions, right? And after doing this, in our index.ts file, what this basically does is it reads this env file and it sets these variables as environment variables. Okay, our environment variables will be accessible throughout our environment, right? So in order to access it, I say process.env and that variable's name. Now I need not put that DB credential directly in the file. Instead, I just refer the env variable so that tomorrow, wherever I deploy, I just need to set this environment variable on the computer rather than storing it on repositories. Okay, are we being clear?
Yes.
Cool. So that we are done with that. Okay, and in order for your server to start receiving requests, in order for your server to listen, it needs to have all the endpoints declared first, right? If you remember in our previous sessions, we first declared the endpoints. At the end only we started declaring our listen endpoint, right? We did server.listen only after declaring all our endpoints. This is because you don't want to call this server.listen before declaring endpoints. If you do this before declaring all your endpoints, if you ping any endpoint, it won't work because this line started serving your API, started serving your endpoints without even setting the endpoints first, right? So that's why we set all the server endpoints in this file. We set all the required middlewares, we declare all the routes, we put everything before even starting to listen to the server. Is this part clear? The reason behind setting all the endpoints before you actually start listening to the server.
Yes.
Cool. So let's get into what we have in API, in our API file. So like I told you, before your server starts to listen to requests, it needs to set all the middlewares. It needs to set all the routes that we do. It needs to catch errors. Okay. It needs to have error handlers. So let's look at what this actually does. Okay. We have the Express app. We have the basic setup. We initialize the app. Don't worry about what these people have. This boilerplate has object-oriented approach. Don't worry about that. Just understand that this file basically initializes your project and sets the middleware, sets the routes, and catches errors. And this order of execution is very important. Okay. It's important because the first thing that any endpoint would need to have is it needs to be set up with a set of middlewares, right? That's why if you notice in our previous sessions, at the top we used a few middlewares. We used Morgan to start logging requests. We used express.json to parse JSON data type. We set up express static folder. We set up helmet and things like that. Okay. It's very important that you do this first. You set the middlewares first before actually setting the routes. So all this middleware is set even before you have any routes. So by default, every single endpoint will be using this endpoint. Will be using these middlewares. Is that clear? So what it actually means is you cannot put this dot set routes before setting the middlewares. Okay, if you do this, your routes will not have these middlewares initialized, and these routes won't be using these middlewares in the first place. Am I being clear?
Yes.
And finally, you have catch errors. These are error handlers. We talked about not found and internal server error, right? So let's say your request, from the front end, let's say we have /users, and let's say the /users goes under the middleware, and now all these padding masala part is done. So let's say we have parsed the content of the request to JSON. We set up all the headers. We set all the logging mechanism, and everything is done, right? After that, you check for setting the routes. Do we have any endpoint that goes under /users? I mean, it can be under users, or it can be under /v1/users. We might even have it routed under API v1. We don't know that. Okay. So let's, for the sake of understanding, let's imagine that there is no user route declared anywhere inside our file. So what error would be thrown? Does anybody remember?
404.
Error 404. Our resource was not found. What happens here is it checks for all the routes, and if there's no routes, the last thing that you do is you set the error handler. If there was no file found, this would be thrown. If there was if there's a different error that's happening, you throw this error. So there's another reason that behind you declaring the error handlers after defining the set routes. This is also very important. So you should just understand that we've set the middlewares first, you set the routes next, and finally you handle the errors at the end, so that it first reaches the middlewares, does some pre-processing, goes to the routes, and if there's no routes, you send it to the error handler. Is it clear? Everybody?
So when we say catch error, it throws an error, like what really happened there? Like it shows a message or something?
Yes, we look at one error handler. So we talked about internal server error, right? So look at this definition. So let's say our endpoint was not able to process it, our middleware was done, our routes, it did something, and some error threw up. So I told you whenever you have this internal server error, it needs to do something. Your question was exactly that. What happens when an internal server error is thrown? You remember we send response using the res object, right? We have the response object, and you send the response using that object. So over here you set the status of 500. Let's say this is 500, and again you set a JSON response so that the guy on the front end knows this was specifically the error that happened in the background, that happened in the backend, right? And when you do response.send, you send this. So basically what you're doing whenever you throw a error handler is you send the error as a response to the front end. So that's basically what's happening, right? Is it clear?
Okay. So we like the catch error's main function is to like show what error really happened.
Exactly. It's just to give back a response to the front. If you don't do this, the front end will not really know what actually happened in the backend. It's just a way to send information about the error to the front end. So now the front end developer would probably be able to debug what might have been wrong in the first place, right?
Yeah.
Cool. So after our declarations, let's get to the routes actually. So I told you that we set the routes, and we have two basic routes set up. Does somebody know what this API v1 would be? We just looked at that concept a few minutes back. Usually you put a controller here. You define the endpoint and you define a controller. And now when I say use, we obviously know that this is going to be a router, doesn't it? Something would have been routed inside API v1, and that is going to be mapped to the v1 endpoint. So if you remember, we talked about API versioning, and now we are doing API versioning by URL. So we talked about 3 different ways you can achieve this. In this boilerplate, in this project, we will be using the first method. You will be versioning your APIs using the URL parameters. So whenever somebody declares a totally different new version of the API, what would my option be? What would I do? I declare another endpoint, that goes under version 2, and probably map a router that handles the version 2 of the API. Is it clear? This is how you achieve API versioning through URL routing. Is it clear?
Yes, bro.
Cool. So let's get into API v1 and understand what's happening here. Okay. If you look at this, file API v1 for the folder, This is what we actually imported in the base, in the API. So the first thing that is read by any JavaScript compiler when you import something from a folder is the index file, right? It's very common. Even in HTML, you might remember that the first thing that loads in any server is the index.html file. Do you remember? Yes, I think you remember. So the first thing that gets loaded is the index.file, index.ts file. And if you notice, we declared a router. Okay, we declare a router, and this router is gonna be having an endpoint, and this endpoint probably has the routes. Just give me a minute. Yeah, sorry for the disturbance. Am I audible? Let's quickly be done with this. Is everybody here?
Yes.
Yes.
Okay, perfect. So now you understand what these routers are, and when you look at this file, I think you would probably now be able to understand how these things will be routed. So in this route file, we are gonna lay out our entire project like this. For every resources, you will be creating a new folder, and in every folder you will have a route, you will have a route file, you will have a controller file. Okay, we are doing this because in routes we will now be able to understand what are the routes that might be in any endpoint. So you would probably define all the controllers inside a particular file.
I is doing this. It's not.
Yes, I'm sorry. Okay, is it visible?
Yes, it is.
Yes, perfect. So we will lay out our entire project like this. You have all these resources. For example, you have a resource that goes under users. For every resources, you will have a folder, and on every folder, you will declare a route file and you will declare a controller file, right? And you already know what a controller is. It's basically the functions that you map to routes. And in the routes, you import all the controllers and just set it to a route. So you know how to route endpoints. So let's say you have users.post, or you can also probably do the second version of, the cleaner version of doing it. You declare a route and you set all the endpoints that goes under it. You would probably do get, and you do controller.get users. Is it clear? You now know what is happening here, right? Yesterday it was really ambiguous and you didn't know what this boilerplate actually does. So now when we looked at routers and when you understood routers, it's pretty much clear now, right?
Yes.
Okay. So in order to have other endpoints, other resources, you would probably create a new folder and repeat the exact steps that you have over here. The one thing that might be new to you is this part. Okay, what are these? Can somebody recall? Whenever we set a parameter, this does not have anything to do with JavaScript. This has something to do with another thing. What is that thing?
TypeScript.
Perfect, TypeScript. In this boilerplate, we've used TypeScript to set the request type. So this variable, you can of course do it without setting any types, but we are doing this so that we can minimize the errors that we might face. So now when you when you set the type prior to even using it, let's say I have the response object, and let's say I'm gonna set call a method that's not even existing on this. Let's say I do jump, and this method is not gonna be available in this response endpoint. It knows that this method is not available in this response object just because we type parameterized it. So if we wouldn't have done this, our JavaScript code would probably not throw any errors, right? Because JavaScript does not have any types. Your JSON objects can probably throw an undefined error when you do this. So now you know the power of using TypeScript, and it solves a lot of problems prior. Okay, so I want you to just go look at the boilerplate again, or maybe you can probably start using it. So let's quickly start the endpoint and be done for the day. Okay, in order for you to start the endpoint, let's do something, and I'm gonna probably set the users. Okay, what's the first thing that you do? You would probably install your dependencies, right? And after doing that, you would say npm run dev. When you look at the package.json file, I've declared this dev script to basically start your server and look for all the TypeScript changes. Okay, so I do npm run dev. So my server has started. So when I ping this file, when I ping the endpoint, it says welcome to this boilerplate. Okay, so we were able to successfully start the endpoint. Tomorrow when we come back for the next session, we will look at how we can set Prisma in a better way, and how we can actually migrate database schema to and from the database. Okay, we will actually build an endpoint. The API that we will be building over the next session would be a blogging API. So it will be the backend for a blogging platform. Okay, we thought we'll do a job platform. I think it's more easier for you to understand when you build a blogging platform. So that's it about today's session. We talked about a few things. We learned about what databases are, and we even walked through the entire boilerplate, and now I think you have a better idea of what's actually happening here. And the only thing that I left out is this folder that goes under helpers. Helpers are basically helper functions, and over here you'll declare all the functions that you would probably use in many endpoints, right? Let's say you have a function that sends mail, and you want to be able to send mail through different endpoints. You want to call the same function in different endpoints. To do that, you will just define it once and import it anywhere you require it in the entire project. So I think that's pretty obvious when you talk about modules and modular programming. So now you might have an entire end-to-end understanding of what this boilerplate does, and I don't know, Jacinthar might be letting you know when the next session would be. Then we will start to we will finish building our entire blogging platform's API on that day, and we will set our required authorization. So that would be the final session, and after that we will be having a task that you might need to complete. And yes, so that's all about the workshop. So thank you for coming today. I hope you learned a few concepts. So is there any doubt? You can always ping me or come back here during the office hours. So Jacinthar, you might want to say something.
I think you covered everything.
Cool. So we will be letting you know when the next session would be. So until then, have a good weekday, or all the best for your exams. Cool.